Okay, the next topic that we are going to talk about is covariance. But before that, we are going to talk about a more familiar concept which is known as variance. We can define the variance of x as 1 over n sum of x minus the average value, the mean value for all the x's that we have. Basically, it shows us the Hausdorff distribution of the data around its average. It can also be written as one over n squared sum over I sum over j 1/2 xi minus xj squared. This is writing that without directly referring to mean. Covariance is like variance, with the difference is that in case of covariance, we are gonna have two sets of jointly distributed real valued random variables that can be x and y. We want to write that in the same format that we wrote for variance. It's gonna be like covariance of x and y equals to 1 over n sum over I, the first variable, the difference between the first variable xi and its average times the variable yi minus its average. That is how we define the covariance. In the covariance that you saw in the curve fit function, we have the similar case too. We are actually fitting for A and B. So our covariance matrix in this case they're gonna have these terms: covariance of A and A, which will be equal to variance of A, covariance of A, B, which as we defined there, going to be 1 over n AI minus average of A, BI minus average of B. The other term that we have is covariance of the BA, and finally covariance of BB. Okay? And the way that the matrix is actually covariance matrix is defined, it's going to be like this. So you had both A and B terms. Imagine this is A, this is B, this is A, this is B. So this is going to be your covariant of AA. This is going to be covariant of AB, covariant of BA, and covariant of BB. So for uncertainty in your A fitted and B fitted, you actually used dA, you defined it as square root of covariant matrix 0, 0. Which one is 0, 0? It's the first element up here, which is covariant of A, A. As we talked here, we mentioned above here, which is variance of A, square root of variance of A, and as you know, that is gonna be your standard deviation of A. Similarly, for uncertainty in B, you had covariant matrix 1, 1. Which is gonna be, which term? This term here, which is gonna be covariant BB, which is gonna be a square root of variance of B, or as we can also write it as standard deviation of B. That is the meaning of the covariance in the kerr fitting function.